everyone to the Data Science Speaker Series. This series is sponsored by the Data Institute, which is the umbrella organization for all data science and data engineering programming and research that happens here at the university. So students, welcome as always. It is a pleasure to share space with you. To our guests, welcome as well. Thank you so much for being here. We are very excited about our speakers today. We are welcoming back both Mars Lan and Rishi Mohan, who is an alum of our MSDS and data engineering programming. And this promises to be an eye-opening session on the role of artificial intelligence in modern data science workflows. So in a field buzzing with hype, this talk will cut through the noise to examine how AI-powered tools are actually transforming the way data scientists build, debug, and deliver code. From practical frameworks to real-world demos, Mars and Rishi will explore the newest innovations shaping the data science lifecycle and show how AI is becoming a true co-pilot for the modern practitioner. Without further ado, I'll hand it over to you.
Can you hear me okay? I'm really glad to be back again. This is actually my third time in the past 4 years giving talk at this particular forum. And Rishi, also this is the second time I'm pairing up with him on this one. As Liz mentioned, Rishi's graduated 2 years ago, I guess? Maybe 3. Okay, well, technically, that's a data concentration, yeah. So if you have any question about, how is it like studying here and graduating, finding a job and all that, he's the guy to talk to afterward. Cool. So today we're here to talk about AI, and as you probably heard this numerous times already, it's the hottest thing out there right now, but in the context of data science. But before I start, because this is a talk of AI, I try to use as much AI as possible, mostly on generating the images. So if you see your face in there, don't get it wrong. It's just AI hallucinating. Quickly talk about myself. I'm currently working at a startup here in San Francisco called Cribble. Previously, I co-founded and run my startup, Metaphor, and before that, I was at LinkedIn and Google. Got my PhD from UCLA and my undergrad and master's from a small university called University of Auckland in New Zealand. And Rishi.
Yeah, my page isn't quite as detailed. But similar to Mars, I am now a software engineer at Cribble as well. I was previously with him at Metaphor, just during and after my graduation of the MSDS and data engineering concentration. So I am from cohort 12, you are 14.
Yeah.
Thumbs up, awesome, I know how to do math. Before the MSDS, I went to the University of Illinois Urbana-Champaign and studied industrial engineering. So I'm not a computer scientist. I kind of figured out how to do it, and I hope you all will too, and take advantage of the tools that maybe we'll talk a little bit about.
Cool. All right, so let's talk about what starts the recent craziness in AI. All of you are probably aware of this thing called ChatGPT by now, hopefully. But can you imagine, it's only 3 years. It's only been 3 years since it was launched originally. And let's see what happened ever since this thing hits the market. $80 billion in VC money invested in more than 70,000 startups. These numbers are probably a little bit outdated. It was taken a couple months ago. Now maybe already double, who knows? Obviously, if you're ever looking at the stock market, you probably realize there's a stock called NVIDIA that's been going up for about 10 times ever since ChatGPT came out. So AI hardware is also selling like hotcake. It seems like everyone's looking for more and more compute. Okay, and there's also some really good news as well, right? I mean, this is a very interesting study, if you're interested in reading into it. So some claim that AI is able to beat human experts in many areas, especially in biomedical areas where traditionally AI has always been strong on, but now it's actually showing to be very useful. And funny enough, because we're in academia here, so a lot of papers have also been generated by ChatGPT, it turns out to be. So, not so good. Also, on the not so good side of the story, if you're ever paying attention, you probably realize there seems to be a difficulty in finding jobs as new grads in recent years. You can argue whether that's AI induced or not, but the data basically speaks for itself. Computer science used to be the hardest major where you have no problem finding a high-paying job. It turns out that, I think this is last quarter probably, this data was released by the New York Feds. It was actually the sixth, I think, highest major that's having difficulty finding jobs. Go figure. And it's not just Feds are saying it. If you look at the news, you're probably seeing a lot of these titles that came out saying, hey, you know, big tech company laying off thousands of people because of AI, right? AI replacing all these folks. It's difficult to say if that's reality. It might be a convenience excuse. They're going to lay off people anyway. And if you read into it, some of these are real developer people have, you know, technical skill being laid off. Some of these are not, right? Supporting staff and all that. So AI is definitely making a difference, but this is some scary numbers here, right? So 500,000 people lay off ever since 2023 in the tech industry. And you know, some of you will probably be looking at this and say, oh my God, what's going to happen to me when I graduate in about a year? Well, fear not, we're here to help you. Hopefully, we'll put you on the right track, you know, make you a lot more appealing to companies out there, and also make you more productive. All right, so now I'll get into a little bit of you know, backgrounds on the Gen AI stuff. These are very interesting pieces, but I don't intend to turn this into like a technical discussion. I'll sort of fly through some of the topics here. If you're interested, I believe most of you actually go through some courses around these same topics as well. So otherwise, you can always keep it to you. There's plenty of information online. So what is generative AI? Well, what makes it so powerful? First of all, you need a lot of data, okay? Then, you need this thing called large language model. And the current most popular architecture is called transformer, which we'll get into a little bit. And this model will basically turn all these data into gold. Well, not quite. You also need the third component, which is called reinforcement learning, fine-tuning. This is the thing that makes this language model, which looks like a glorified, you know, predicted input model, into something that sounds like a real helpful you know, AI copilot or assistant. So everything started from this paper, which is actually in 2017. Highly recommend read it. At the time when it was published, it wasn't a huge deal. People were like, oh, interesting. But no one realized that this is going to really kickstart the whole AI evolution until like 5 years later or something. And this is the architecture of a transformer. And this is definitely not the latest. This is like GPT-2 or something. Okay, so it's still not as smart as you imagine. But ultimately, if you look at this particular architecture, what happens is it's taking in all these terms, right? And then it's considering all the relationship between these terms, and going through this multi-hat attention architecture mechanism is able to predict what comes after that. What's the most likely word that comes after that? So once again, it doesn't sound like something grand, but it turns out that if you feed enough of information into this model, it actually starts having this emergence behavior, which means it's not only understanding how likely the next word will be, it also able to start extracting meaning from texts, and then long-range text as well. So the famous example that people like to give is, you know, think of it as you're reading a detective novel where so imagine you're reading a detective novel, and it's a very long novel. It doesn't reveal who the actual villain is until the very last word of that entire story. And then you have all the words before that as your input. So at the last sentence, you say, well, the culprit is, And if the computer is able to predict that next word accurately, based on all the context that was given before, wouldn't it become intelligent in that sense? It truly understands the entire context and able to predict it. Not just, hey, what's more commonly going to happen as the next word. Is given all that context, what is the next thing that's going to come? Okay, so that's large language model. But large language model is so yesterday. The latest thing that's happening in the past, I'll say a year or so, is called large reasoning model. Okay? So what is that? That is really a large language model that with the main concept called chain of thought. So think of it as these models are somehow kind of lazy. It was trying to tell you the answer that's the easiest for the model to print out. But if you push it really hard and say, wait, don't just give me the answer yet. Think very carefully about what you're going to say, all right? And then think even harder than that. And then keep pushing the language model through that loop. It's able to produce some pretty amazing reasoning capability. That's essentially what large reasoning model is in a nutshell. Think of it as we are not only going to give you a fixed context and then produce a meaning out of it. I want you to use your own generated information to feed yourself as additional context and keep pushing yourself until you really reach the correct answer. Here's the graph showing some of the latest models, the frontier models. On the left, you see the light purple. These bars here, these are all reasoning models, okay? And then one on the right, these are all kind of very similar model, but doesn't have the reasoning capability. Obviously, this is kind of an abstract index, intelligence index. But think of it as how much better the answers produce. And you can see there's a real difference between the two when you start putting in reasoning capability into the model. And many of you probably have seen this in one form or another, but the most pronounced signature is when you type into ChatGPT or Gemini or something, and then you start seeing that the response come back with thinking. That's the typical thing. It's like, I'm thinking right now, and then it takes a little bit of time before the language model is able to finally spit out some answers. That is the sign of a reasoning model. And some of the latest model is able to auto-adjust based on the complexity of the question to decide whether you want to go down this reasoning, push your language out a really hard route, or the nice and easy route and quickly spit out the answer right away. So these reasoning models are very good at multi-step tasks. So if the task involves multiple steps to reach the answer, this is actually very, very good. A good example would be like a mathematical proof. Right? It requires proving multiple things before you reach the answer. There's no easy way to jump directly from the question to the answer. Those are things that reasoning models are really good at. Also, it has the ability to backtrack, right? It's not just like pushing yourself really hard and then keep going down the rabbit hole. It has the ability to realize, oh, actually, the particular path I've taken down is a dead end. Okay, let me go back and then start trying a different approach. But the biggest drawback of that is it's very expensive to train, and also expensive to during inference time. As you've probably seen, where it takes a long time to spit out the answer, you can imagine how many more tokens it has to go through before you reach the answer there. So roughly estimated, takes about a couple $100 million to train something like this, and also takes 10 times as expensive. That was the conventional wisdom until that is no longer the case. Some of you might have seen this news. It's no longer news because it's more than 6 months in the AI world. But a small unknown company, not well-known company in China called DeepSeek, has come up with a very clever way of able to sort of use a very cheap mechanism to train the model, and able, or more importantly, to infer the result. And this has shaken a lot of belief here in the U.S. thinking, only the frontier lab here in the U.S. is able to achieve something like this. There's some controversial around it behind us, and people are saying, maybe they are distilling a frontier model rather than training their own, and so on and so forth. I think even a recent news came out saying that they significantly understated how much money they actually spend because they're not including the foundational model training costs and so on and so forth. But I think there is definitely a big push on can we make this reasoning model more universally available at a lower cost point, lower price point. So here's another interesting paper, I encourage you to read it as well, that came out of Apple. People joke about how Apple has not released any model, but released a good paper. But these guys here, they done an interesting evaluation of the reasoning model, and then the conclusion was saying, hey, the reasoning model is not really that great, right? If you actually keep increasing the complexity of the problem, at some point, the reasoning model start giving up and getting lazy, so to speak, and saying, I cannot solve this. And then the accuracy fall to a non-reasoning model at that point. The reason why I say this is controversial, because once again, I don't think the conclusion is universally agreed upon, but it definitely points out some interesting aspect and some thought-provoking questions about are reasoning model really understanding the problem, or is it just memorizing enough of things that it seems like it is able to do rather than the non-reasoning model? And here's another funny thing. All three, it was one of the first reasoning model that came out, and you can see here, a simple question as how many words in your response to this prompt took 8 minutes, 50 seconds to crunch. And obviously these figures are all estimated because there's no public information about how much it takes to run these and all that, but people estimated this takes about 115K tokens and about $2 price to answer a simple question like that. So that's some of the downsides of reasoning model. You can think of it as, if you ask an elementary question to like the world mathematics PhD, the smartest guy in the world, maybe the guy will actually overthink it. That's something sort of along this line as well. Maybe that's what's happening. Sometimes, simple questions best not to think too hard on. And some of you might have seen this XACD. This is ancient by this point, but it's a famous XACD comic script that talks about in the old days, one of the biggest issues that programmer gave to the boss for not working is they're waiting for the thing to compile. I think in the future it will be like I'm waiting for my AI model to think. All right, moving on to the next topic. This is another hot topic that came probably in the past year or so as well. It's called AI agents. Okay, you probably have seen news about it or startup that claims that they're doing AI agents and so on. But it is actually not very complicated. So what happens is now people believe that I have a large language model is pretty reasonably good at, making decisions and evaluating conditions and so on and so forth. But it is still a model that's running somewhere in a closed environment, right? So when you ask the model to do actual things for you, for example, buying something online for you, right, or write this report for me, that's not a bad idea. Do some research online and then produce a final report for you, right? You need to give the model ability to access information beyond its sandbox, so to speak. And then after they access the information, the model has to think sort of as a human almost, internalize this information, and then take further action. Right? Is there more research needed, or have I reached a good point? Right? You want me to buy a shoe? Is this the right color for you, and so on and so forth. So this particular loop, where you basically put the large language model on this loop of planning, executing by the means of connecting to the external world, getting information, making actions, and then observe the result and decide whether you're done with the task. If not, do more of that. This is essentially this is the essence of agents. And then you notice one important part of this whole picture is where you have to be able to take actions and tools. Right? So it's not just within the own confine of the large language model itself. It has to be able to access the external world, like a human. Right? And this is where this thing sort of come into play. MCP, Model Context Protocol. This is also a pretty recently defined protocol by one of the top frontier
MIT AI lab in Tropic. And it's basically, think of it as giving the large language model ability to access things, where the tooth thing that you saw in the last picture came from. Because it turns out, if you can give large language model as much context as you could, the more context you give to it, the more ability it's able to, the more it will able to perform on those. So think of it as a service discovery and tool stacking protocol. So it allows a large language model to access things like database, your browsers, your actual IDE code, or some other APIs out there. And it's claimed to be like the USC port for AI application. Think of it as being able to plug in external tools into the AI. And just to show you how popular MCP is, this is a Google Trend graph, as you can see. It came out beginning of this year, I think, so February. You can see where this thing start picking up. And now it is actually more popular than the word data science, believe it or not. And here's another funny meme that comes out. Ever since the NCP spec was released, there have been a lot of companies jumping on the bandwagon. Everyone was trying to build an MCP server for their service and whatnot. So now you actually have an overflow of MCP servers out there, and people are actually using it. Obviously, the biggest fear in all of that is, what if the large language model does something stupid? Right? If you give it an API that has the ability to delete your data or do something harmful to the world, is that really a good idea to plug into something that is known to hallucinate from time to time? So that's why the adoption of MCP right now is still kind of limited. Mostly, I think, engineers are the one that are sort of jumping on the bandwagon at this point. But the hope is, if we can truly have real safeguard in the AI models and whatnot, this sounds like a really good idea to give AI ability other than generating text or images. All right. Here's another interesting idea that's also introduced recently for vibe coding. Some of you might have heard of it. But the idea is also very simple. If large language model is so good at generating code, why don't we just let it generate code all day long, right? Instead of helping you as a copilot, you're gonna basically YOLO and then just give it to the large language model and say, I have this thing in mind, why don't we go and write something for you? This term was coined by a pretty famous, coined by Andrej Karpathy, pretty famous figure in the AI world. It turns out that he said, hey, look, I was able to code something complicated by just talking to my computer without lifting a single finger. That seems like a really good way of programming. And ever since this came out, there has been various different people supporting and criticizing and whatnot. Some startup bet their entire startup on this as well, obviously. But I think the mileage may vary, and very shortly, Rishi is going to show you a version of it, and hopefully, he will show you that it's useful and how it can be useful. And finally, before we jump into the actual demo, I also want to point out to this very interesting study that came out recently from MIT. They basically just look at people's brainwave and see what happens when you're using a large language model versus doing web search or just purely using it to solve a problem. So the sort of the high-level conclusion is that, not surprisingly, if you rely on LLM too much, you're not thinking very hard. And if you are thinking without these tools, you use more of your brain. So, the long-term impact of this is obviously remain to be seen. But I think this is a very important idea to take to heart, right? Treat these, AI tools as a tool. Right? Don't use it as the only way of doing anything done. Because if you rely on it too much, you actually lose your critical thinking and everything. So think of it as an accelerator rather than a replacement. All right. I want to wish you for some cool demo.
Yeah, if you've ever heard this phrase, the demo gods, it's a very common thing anytime you have live demos. It's basically guarantees that if something goes wrong, you can blame somebody that's not yourself, and you can blame the demo gods. So in this case, I will blame probably something Nadella or Sundar Pichai if something goes wrong, because I'm using Gemini for this one, but look, I just work here. So Mars talked a lot about, I'm just going to turn this on. Mars talked a lot about fancy new tools, like MCP, agents, agentic. What's an agentic workflow? I have no fucking idea. Sorry. I don't know. But one thing that can be sort of ascertained is LMs are not good at super giant tasks. They might claim to be good. They'll say, oh, I'll break this down and I'll create to-do lists. A to-do list is the same to a model as it is to you or me. It is, here's a big thing that I need to tackle. Can I discretize that into a bunch of tasks that give me a little yippee moment when I check that box? I get the little yippee. I use a to-do list. It works great for me. And what we found is that it tends to work pretty well for some applications too. Now, one of the most classical things that a data scientist or even a software engineer or machine learning engineer, whatever your title is, you end up working with data at some point in your life. And the first thing you do when you get a data set is you do a little thing called EDA, exploratory data analysis. I'm sure you've spent untold hours prompting models to give you funny looking EDAs. And you had a great presentation. One of you probably won some extra credit for it. So good for you. In this case, I love EDA. It's fun. You get to create good graphs. But it's so time consuming sometimes, especially when you deal with data sets that are like GeoJSON. If you work with map specific or really weird time concepts, all these things kind of bundle up over time. And it makes working with the data itself harder than it needs to be, right? You want to focus on the story. What is the data telling you? You don't want to focus on what is the library I need to import and what is the module I need to use to get this thing to render. And so this is me kind of YOLOing a little bit of EDA. As the repository is titled YOLO EDA, I'm just going to see if I can get it to do something interesting with this data set. So I've got a data set, SF pothole reports. I'm sorry if it's not big enough. It's going to be too big if I make it any bigger here. It's got some things about San Francisco. The roads in San Francisco kind of suck. Not sure if you noticed, but and it sucks all over the city. So I want to know certain things about it. Can I predict how long it takes to repair a pothole depending on where it is, or like when it was reported, or how severe it is. And of course, these are location-based attributes. A pothole is somewhere, end time, end place. So maybe there's some relationship there too. So I'm going to cheat a little bit here and copy paste my prompts. You're welcome to see them. I'll upload this repository later, but it's just so I don't misspell anything. It's probably fine if I misspell things. Like, I've got this awesome prompt. This works, by the way. Positive encouragement and negative reinforcement absolutely work in prompts. If you say kittens will die if you do not get this right, it does better. This is entirely anecdotal and not empirical at all, but it does. I'm sure there's papers on this. So let's start with the most simple thing, and something you probably can do in your sleep, which is, let's, whoops, paste that in. Let's just load it in and take a look at it. So I'm just going to use my YOLO model here, which is Gemini, and I've turned on everything that lets it do whatever it wants to do, which is never do this, by the way, never do this. Don't give it shell access, don't give it internet access. You should be very careful on what you let your model do. But I'm not. So we're just going to see what it does. In theory, what I want it to do here is take a look at the CSV and look at the columns. Like, that's the first thing we always do is let's look at the data, let's look at the missingness, let's look at the shape, let's look at what the patterns we see in every column is. And I've somehow convinced it to actually work in notebooks. I'm sure you've all tried doing this in notebooks. It's not super consistent sometimes. If you actually want to take the full advantage of these models, learn to work in files. They do much better. And you will become a better programmer, a better engineer because of it. You'll learn how to deal with imports and modules and all these things. But in this case, notebook is home ground, so we're just going to go with that. Okay, yada, yada, yada. Thank you. I'm sure you did everything correctly. Let's just run it and see what we get. I have absolute trust in the model, which is never something you should have. But the key here is that I am focusing on EDA. EDA is a generally rote task that we know the rough pattern for. We know what we want to do with certain features. But we don't want to spend our time in the complexities of accessing the data in a certain mechanism. So we've got 10,000 rows, we have 9 columns. I've got some fun neighborhoods here, looks like quite a few of them. There's a really odd object in this column here, so I'm going to have to deal with that, right? Data cleaning is some of the most monotonous part of data science, but it's absolutely essential, garbage in, garbage out. It applies to generative models, it applies to predict, regular forecasting, category, whatever you have. If you don't have good models, good data, you're going to produce junk. Same thing here, we've got a weird JSON object here, and some of them have multiple columns, no, this one doesn't, but I think there's another column in here somewhere. If I look, there should be like a reporter name or something. Yeah, so that's not going to work. We're going to want to unroll these objects and probably throw them away, but at the same time, it should be a clean, consistent data set. So now that we've seen this, I bet all of you could type this faster than what this whole process does, but that's mostly because I'm standing here talking. But the key here is I don't want to spend my time focusing on these details. I want to be focusing on the data itself. And this allows me to look at this metadata without spending the cognitive complexity on accessing it. So I have some missingness. I have some, look at distributions. Okay, Sunnydale has some pretty awful streets. That checks out, I think. Pothole. Somebody's got 55, this is the, maximum? 55-inch pothole. Does that seem right? I don't think that seems right. So there's probably some outliers in this data. I'm not super good at latitude and longitudes, but the minimum here, 0.43 versus 0.28, that's the mean, sorry. Minimum, 0.51 to 0.28. That's a pretty big variation. I think that's like 20 miles or something. So there's probably something wrong there. Maybe there's some geographic outliers too. And so I don't want to be necessarily trusting this data right off the bat. So let's see if we can clean up some of this inconsistency, or even look further into some of the next columns. Just for fun, let's see what we have in the neighborhoods. This neighborhoods one. I'll type this on out right now. Yeah, what is a neighborhood? Thank you. You're so helpful. Autocomplete. Okay, cool. We've got a bunch of these. That's not very helpful. Oh well. So there's probably some inconsistencies in this data, and we're going to want to parse through that and see what's going on. One inconsistency that I'm pretty sure exists is the names here are not always going to be the same. So if I look right off the bat, I have a non-capitalized neighborhood name. Non-capitalized neighborhood name right here, right? That is going to be considered a distinct category if I want to use this predictively, and I need to standardize these in some way. If this was a more complicated variation, I would probably use a little something called regex, or regular expressions. Regular expressions are like a weird arcane science that take a very long time to get very good at. And most of the time they're a foot gun in that you write a bad regex, and you spend hours processing it because it's accidentally processing a 300-character string every time for every row. So in this case, I don't want to do that. I want to let it do the processing here. So I've kind of figured out, okay, there's some inconsistencies. We've got a weird object in the severity column. I have multiple variations of certain neighborhoods. I think many times these are all abbreviated interchangeably, but in categories, we don't want it to be like that. And we know that there's this kind of bundled up column in there. So I'm just going to see if it can do its best to handle that. One really fun thing here is I need to accept all these changes, because I don't like these pop-ups. I think there's a way to deal with that, but again, probably not a good idea too. So let's see what it does. So, being the data janitor is not really that fun. Sometimes, this is 9 columns. 9 columns is not a lot, 900 columns, that's maybe typical. This is 10,000 rows, again, not a lot. You might have 100 million, so you're pushing data into gigabytes or terabytes. You also want to be efficient with that. So this could be some randomly sampled data set. And whatever optimizations you make, you want them to be efficient over this large portion. You need to convert that to Spark. You need to do that in a different way. In this case, we're going to use Lambda functions, which are pretty fast. They compile their bytecode, and if we vectorize them, they're pretty good. So that's probably about as good as we get without going to polars for faster data access. And it parses this out into a different column. So maybe it splits this out in the way I want. So again, in the greatest form, I YOLO it, and let's see what we get. Okay, so capitalizing categories is a very common way to deal with inconsistent casing, all this stuff, so that's dealt with. I've got this reporter name, which is that nested object we saw. We see that most of it's actually kind of missing. 7,600 of those values aren't filled. So maybe it's not that useful. But regardless, we have this in a preserved state. We have this in a way that we can access it if it happens to be useful. Personally, I don't think that data existing in like 25% of your rows is that useful, but we might discard that. But this is about determining that and determining those relationships. What's some other stuff we see? We have consistent access to source, so that can be another categorical picture. The next step is when you're dealing with funny looking neighborhoods or geographic data, the best thing you can do is look at that on a map, because data is just lines in a CSV or in a JSON, but there's no comparison to its context in the real world. Data is recorded numbers, but it's up to you as a data scientist to figure out what that means. And that sounds very fun, but all I'm going to do is ask it to create a choropleth, which is a great way of displaying concentrations in distinct geographical regions. I don't have the code to write a choropleth memorized. I can do from matplotlib import pyplot SPLT or something. That's about the best I can do. So let's just have it do it, because really good-looking visualizations are some of the easiest ways to win over stakeholders whenever you come across a project. If you have something that they can look at that tells the story that your data does, it makes it much more compelling. And good visualization, yes, this exists, I know it does. So I have a data set also available that represents the GeoJSON, which is a polygon of geographical boundaries of each of these neighborhoods. It's very conveniently the same neighborhoods. I don't know how that worked out. Most of the time when you're dealing with geographic data, it will be distinct groupings, and you'll have to write some funny latitude-longitude matching logic to dump things into there. This could definitely do that, because we have those predefined boundaries. So, in the spirit of this demo, that's not right. No, why do you do this to me? Oh, goodness. Okay, what are you merging on? Name, neighborhood. This is completely unintelligible. Number of what is this going on? Yeah, this is the great wonders of live demos. So you can see my backup. I thought So let's just see what that's supposed to look like. Remember, guys, large language models are not deterministic. They are extremely stochastic. Even if you set the funny temperature parameter, they suck. They will not give you consistent answers. In this particular case, I'm supposed to get that, which looks a lot better than the weird scaled one from before. That's okay. We're going to keep figuring this one out. But essentially, this tells the story. So this data spans, if we go back to the analysis, we can see that it spans, where's my min and maxes? Hello? Okay, we can see, okay, it's a data object. So the data is between 2023 and 2025. So there's not 10,000 potholes currently present in, there's not 300 potholes currently present in, the outer mission. There might be, but I don't think there are right now. Maybe in the last couple of years. So it's generally pretty good, these visualizations, but the demo gods have failed me today, and so things crash and burn. That's okay. I will continue with the summary of what has been done previously. So I love this plot. I love looking at it and seeing that not every neighborhood has the same distribution of potholes over time. Not every neighborhood has that same representation. But I also don't know, what is this? What is this little neighborhood right here? What's the name of that? So sometimes I wish I could just interact with my charts. And maybe you've used Plotly. Maybe you've used some sort of animation library built as a plugin from Matplotlib or Seaborn. But interaction is another great way to tell compelling stories, because there's nothing that executives like more than a fun dashboard that they can go click on and look at things with. And it also helps you interact with the data that is more native to the way we think as humans. We don't want to be writing code to select neighborhood name where equals that stuff. So in this case, I can instead select the outer Richmond and see what's next to it, Sutro Heights. Okay, sure, this is official data from the city of San Francisco. I wouldn't call that Sutro Heights, but what do I know? And And so we can see the pothole count there, and this is interactive. And I didn't write this code. This is a single giant plotly call, but this is me requesting with the really excellent prompt, wow, fire. You make it interactive. It works pretty well. So with this done, we can see the kind of way this works out. But what I want to do is also start trying to figure out what the relationship to my target variable is. Maybe I need to pick a target variable. In this case, I said, let's predict the time it takes to fix a pothole, to resolve that. So in this case, that's a time delta between the date it was reported as repaired and the date that it was reported as a pothole. And I also want to make sure I filter out my outliers. It's not easy to tell on this graph, but there's outliers in Oakland. I don't think Oakland is part of the city of San Francisco or the county of San Francisco. It's definitely not. So there's some geographic outliers, but I want to handle those, filter them, and create a repair time, my target attribute, that I'm going to predict against. And I want to see how all my variables relate to that target column. So instead of actually doing the math here, sometimes date time objects are weird to work with, sometimes time deltas are weird to work with. I don't want to think about that right now. I want to see the relationships. I'm just going to ask it to do it. And we get our target column, and we start getting some distributions. So pothole depth versus repair time. Oh my. So we can, I'm sorry, this is not that big. We can see that there's maybe a rough proportionality to the repair time and the actual measured depth. We can see that there's an assigned severity score. There's maybe a vague linear relationship between this assigned severity score and the depth of it. We don't know what severity score means. It's up to you to determine, go to the data dictionary and determine what does that actually mean. Is it proportional to the deemed urgency of the city inspector? Is it proportional to how much traffic is on that road? Is it proportional to, did the mayor see this or did Joe Schmo see this? All of these things add context to the data that's not present in this column. And we get to see some of our other distributions. So this is super hard to see, which is really great. But I also want to know, how is it geographically different? How is the repair time different depending on where the source of the report came from? And I also want to know, does it matter? So it turns out maybe some neighborhoods have different distributions. Maybe some report sources are roughly faster than others, probably not. But what's interesting is we also can quickly see time relationships. I think it makes sense that there's more potholes in rainy seasons because water gets into asphalt, breaks things up, I buy asphalt. And so we expect to see January, February, December, and to an extent October have some increased spike maybe in the pothole reporting. And we also see that there's probably not that important of a relationship between these two. Again, this is all anecdotal, right? We're not looking at an R-squared. We're not looking at any measure of correlation between these variables. I want to simply know, so I can develop a hypothesis, what are potential relationships. And I can focus on the data more rather than focusing on writing on these charts. And we can also look at some maybe spurious correlations. So I wanted to see how do things change neighborhood to count. Maybe, we know in San Francisco there are some neighborhoods that are a little bit wealthier. There's some neighborhoods that are not. The demographic of the people that live in those neighborhoods is very different. Some are much more aware of the services the city is supposed to provide. Some of them aren't. So if we see in neighborhoods that have a very high count of reported potholes, but the severity is low, what does that mean? That means that maybe they're over-reporting. So there's some spurious correlation in the geographic location of a pothole to the depth or severity it takes to repair it. So it's also good to easily call out these relationships that may add some, not add context. And I didn't ask it for anything simple. I was like, what about it? What about this? What about this? What about that? And these are questions you want to ask yourself about all these comments. What about this? How do I know? Does this matter? Does that matter? Instead of spending time writing this stuff, it wrote invisible code to do it. Wow, look, it's right there. And I also wanted to see where these things are coming from. Okay, this is extremely useful. I really wish I said, wow, fire, can you make this interactive? But I didn't. So what is this, Golden Gate Heights right here? Okay, so there's maybe more potholes in my traffic areas. Checks out. And then just for fun, at the end of it, I asked it to write a summary. And this is where things get different. The summary sucks, guys. It's not good. The summary says Telegraph Hill has a high concentration of potholes. Telegraph Hill is like 3 roads. And also, if we go back to the chart that it provided us, Telegraph Hill is 36 potholes. I don't think that's quite right. You know, like there's clearly some worse areas. This is maybe a context thing. We talked about this. Maybe it just can't interact with, it can't see the picture of the chart. Maybe it's guessing that this is Telegraph Hill. Definitely not. And it's thinking that there's a high concentration there. It has no way of knowing. But what I want to wrap this up by saying is that it doesn't actually, it's not actually doable to throw everything, every task you have and will have as a data scientist to a large language model. You cannot. There are 2 things. One is that paper that Mars mentioned 2 slides ago, this guy, it's a 204-page paper. I challenge you to read it. It's a very good paper because it's very meta. It'll talk about the garbage that kind of builds up from not using your brain enough. But I also want to play a game. And this game is, these are typical tasks that a data scientist will be faced with as the course of a project. And I want to kind of see, sense the room. What do you think? Is it automatable? Or is it something that's always going to come down to human intuition? And I think I dropped a lot of hints about this in the presentation itself. So, defining the problem. Please tell me if you think, is it automatable? Is this something a large language model can do, or is it something that requires human intelligence? Human intelligence. Alex, is that the answer? Alex says, yeah, what is human intelligence? Is the answer. That's dramatic, yeah. Anyway, so figuring out what the problem is, maybe there's an alert that triggers. Maybe there's some monitoring that fires and says, oh, there's something wrong here. That's not a problem definition. If I get a notification that says I'm running out of resources in this neighborhood. The garbage trucks are always full when I come out of this neighborhood, and the monitoring and the charts tell me that. Is that the problem? Or is there a bigger problem that different data sources can help us identify? Next question, data exploration. This is kind of freaky. Any thoughts? Thoughts? Is this automatable? Is this something that LLMs can at least help accelerate? I see nods. Correct. I did a horrible job in EDA on that data set. There's so much more interesting stuff to see, I think. And I'll talk about why. But data exploration is something that can easily be facilitated. There are purpose-built tools coming out every day. Hex, Omni, all these BI tools will do this at the tap of some NLP, or with some natural language. And that's the same thing, they're just not in Python, which means that complicated, insightful analysis comes to the hands of anybody who can write English or whatever language the models are familiar with. They don't have to be familiar with SQL. They don't have to know the intricacies of pandas. That makes it easier to do your job, so at least part of it. Wrangling, unraveling, shape manipulation, coercing data types, all this stuff. Questions? I see it like 50-50. I put it on it's automatable if you have the right context about it, if you know the intended input and output, but I would also give it a 50-50. There's some really odd JSONs, some really odd abstract objects. You have no idea what you're working with, and you need someone to look at that and say, is this data valuable, or can I throw it away? This is a pretty generic term, development. I think this is the question that every Fortune 9000 CEO is asking themselves, is development automatable? So you, class of 2025, or 2026, what do you think the answer is? Is development automatable? Medium? I agree, medium. I think it is medium automatable, to put the scientific terminology on it. There's definitely things that it's good at. Writing tests. If you are not in test-driven development, if you write your tests after you write your logic, it can do pretty well at writing tests. And it can do pretty well at accelerating certain migrations. But it's not going to be perfect, and you always need to understand the business context around it. Visualization. Thumbs up. Visualization is a hard one, because dashboards are driven by business context, business requirements. You cannot just say, oh, these stakeholders want to see this, and this will come up. There is somewhere in the middle there where you need to know where that data is coming from, but that's the human touch. Experimentation. I don't think you've talked about A/B test, multi-arm bandits, all this fun stuff, but experimentation is, in the data science tech world, it's an online method of comparing multiple treatments to see if they result in a better or worse output. What do you think? Is this automatable? Yeah, probably a little bit. There's a ton of great tools that make it easy now to flip feature flags and see how people react to that. But this is the place where you, as a data scientist, if you're a product data scientist, is going to see the most scrutiny, because somebody wants the justification that this button changing the color, or saying give now versus donate now. They want to know that there is some statistics and math behind it. That math is inherently trustworthy when it comes from someone who has a master's degree and is sitting across a table. It doesn't come so great when it comes from scrolling text on a screen. Tuning. So this is continuous fine tuning. This could be large language model tuning. This could be your just parameter tuning over time. It's probably pretty doable. Again, if you set constraints, if you set good test cases, so on and so forth. Documentation. Medium. There's some very typical stuff that can be easily documented. The actual code that you wrote is very simple to understand for models. They know what code is. The output can never be contextualized. The writing the report at the end of the day can be helped but never done fully. Storytelling. No. Storytelling cannot be. I cannot stand here and read off, I could be reading off a teleprompter, but that's not auto-generated. Telling the story of what you found or explaining what you saw in the data to somebody else can never be fully interpreted, because there is a human element in all the data we see. This data is grounded in the city of San Francisco, a city that most of you are probably residents of. That means that there is local context to every piece of those data points. Maybe you reported one of those potholes. I guarantee you didn't. I'll explain why. But the local context, no matter what the problem is always essential in creating an actual answer to whatever the business problem is. I think I've said this word several times at this point, contextualization. And I would put this in the same category. I'm treating it different from storytelling. Storytelling is you've come up with the results, and you want to say, what do these results tell us? How do they guide us to the next path? Contextualization is a broader topic of, is this data relevant? Where did this data come from? Does this data affect the existing sources in some way? Is knowing the human intelligence boots on the ground? What is the reasoning behind this stuff? And the reason I said none of you reported this potholes, this is and another thing, is that data was all synthetic. I engineered those correlations. And I didn't have it generate a bunch of data points. But this is something I think large language models are really good at. And this is something I've used multiple times in doing experimentation with time series forecasting. I want time series. I want to control every parameter of it. Maybe there's libraries that do it. Maybe I want it to produce a data set that behaves in a way I expect it to, so I can check to see if my assumptions are correct. And it did it. I asked it with a pretty long one here, create a data set for me. Create the generator for a data set. Because it creates the generator, I can always go back in and make this parameter, where is it? Instead of 10,000 rows, I can easily go in there and say 100,000 rows. And this is all auto-generated. If I run that, it recreates the data set, which is why I guarantee none of you reported those potholes, is because I didn't report any of them. Nobody reported any of them. Somebody's name is in there, but it's from a fake name generator. So I think that's all we've got for the most part. It's helping you figure out what you can and can't do. EDA is something you should know how to do yourself. I'm just telling you that maybe it's easier to sometimes let the machine help you do it. Thank you. Sorry, I forgot about it.
Okay.
This is the most important slide of this entire talk.
If you want to find a job, look at the blue button. Look at those. And speaking of that, here's a quote for you to chew on. This is from recently an ex-GitHub CEO quoted from saying this. Okay? So, yeah, learn how to use AI. It will help you. But just remember, don't rely exclusively. Thank you for the talk, and we're happy to take any questions that you have.
Sure.
Does anybody have any questions?
Hi, just a small point. Early in the lecture, you showed a slide saying that 95% of AI or radiographic interpretations were accurate. Because of something I studied several years ago, do you happen to know if that was neural network AI, neural network approach, or was it some other?
Okay, the question is about the specific reference I made at the beginning. Yeah, sorry, I don't know the answer to that, but the link is there. You can feel free to look at it. I think it wasn't about that exact figures and whatnot. It's showing you that it is a very good feature to that.
And you bring up a good point, which is that traditional machine learning, what we consider to be traditional random forest, linear regression, all this stuff, is now AI because it's sexy. I don't know the answer either from that specific paper, but everybody's calling things that are pretty mundane in our world AI, and so it very realistically it could be. And in a biomedical field, I'd expect it to be because you want explainability. You want to know why a certain answer came up. But knowing AI doesn't mean you know the transformer architecture. Knowing AI means that you are a machine learning professional. You happen to know generative AI. You have to know both because one has concrete, useful outputs so far, and the other one is still a pipe dream.
Questions?
Thank you for the presentation. I guess mostly a question for Rishi, but what made you want to do the data engineering concentration?
Yes. So a question for me about what made me want to do the data engineering concentration. So I will actually say thank you to Mars for that one. So I worked for Metaphor, a data cataloging startup, while I was in the program. The work was initially advertised as machine learning engineering, which it ended up being a lot of generative AI work. But exposure to making a product work not just as a YOLO demo, but for customers in their environment, and how certain challenges interact with cloud architecture, how certain challenges interact with volumes of data, made me want to just learn more about it. And it was the perfect timing. I was able to continue working at that time, and I think I became a better software engineer, a better data engineer, and just kind of more well-versed. To me, data science is a very large end-to-end thing. It starts at getting the data in, and that could be from the recording time, and it ends in a model. The program does a great job in covering model, the cleaning, the building, the querying, and then producing the model. There's still a bit here to the left, your left, about getting the data in, moving it, storing it, processing it. That was what I was curious about. I'm happy to talk more about the data engineering concentration afterwards also.
Thank you.
Hi, thank you for the talk. I was wondering what you suggest for how can we improve those skills like storytelling that AI can do.
I think those skills has always been important as a successful data scientist, right? Ultimately, you have to think about you solving a business problem for the company or for your stakeholder, and whatever hard work that you've done, at the end of the day, didn't really answer that question in the first place, right? I think in the sort of Gen AI world versions of data science, those skills are even more important than ever. Because it used to be that, hey, look, that's a small part of my job. I spend most of my time, 90% of my time, crunching the data, building model, getting results. In this new world, you might end up spending less than 50% of your time. What do you do with the rest of your time? Right? You are spending a lot of time trying to understand the result. Right? And at this time, it's not your own code that's producing the result. It's essentially somebody else's code, or you and AI co-produce the code. So having that ability to really understand the context and explain to your business holder becomes even more important. I'm not saying that it wasn't important before, but in terms of how we can, improve yourself on that, I think actually, does this course talk about specific about?
There's a communications course which they should be in right now.
So yeah, make sure you excel in that course.
Yeah.
But a lot of these come from how much time do you want to spend on reading other people's work, right? It forms a good foundation of knowing what good quality works look like. So yeah, try to expose yourself to, there are a lot of good reports, database report out there. Right? Look at those and see how top tier data scientists write their own output, and then learn from that.
And then one thing is, so I was before as an industrial engineer. And industrial engineering root cause analysis is a very methodical thing. There's a thing called 5 whys. You end up with a problem or a symptom. You ask yourself why, and then you do that 4 more times. I'm not going to say why 5 times, but now that you have the time potentially to ask yourself why, you have maybe increasing levels of hierarchy of visibility on why. So why do we have potholes? Why are potholes being reported? Why are they over-reported in certain neighborhoods? Why do certain neighborhoods get them fixed faster? So on. You see it from an increasingly further up perspective. The secondary challenge is figuring out what perspective the person you're reporting to wants. They don't necessarily care about the CEO's perspective, but they care about their team scope. And so it's a 2-part challenge, is figuring out why and determining the level at which to discuss it with.
Hi, Sebastian. Thank you for I was wondering, these things like 5 whys are very systemic, and we think AI would potentially be able to do it at some point. Do you think that they will take that human intelligence aspect of this work, and if so, how long?
So the question is, things like 5 whys are typically pre-systematic approaches. Do you think AI can automate those at some point? Yes, no? If so, how long?
I think there's a tendency to think, what else can AI not do, right? Now you're seeing the power of it. Yes, I'm pretty sure AI will be able to ask itself why 5 times. It's probably what the reasoning model does internally anyway. Would it be able to produce something meaningful is the real question. And in some simple cases, yes, I think so. But in the more complicated cases, certainly not. I don't think that, at least with the current model. Right? And then the inherent problem with hallucination and the eagerness to produce answers, whether it's correct or not, sort of hurt at least the AI performance at this point. Right? And that's kind of the human age that we have still. At this point, where you know sometimes to say, I don't know the answer to this, or this is just nonsense. I don't tell you this nonsense answer. But yeah, for how long, we don't know. I mean, this is still a very actively developed area, and it seems like every day someone else, there will be something on the news saying how AIs can replace this particular thing. Remain to be seen. Hopefully not. I also want my job security too. Anyone else?
What is your thought about spec-driven development? It's something what developers should use like day by day in your.
Sorry, can you repeat that again?
What did you thought about spec-driven development?
Spec-driven development. Okay. So the question is, what do you think about spec-driven development, and whether that's something that developers should use day to day? And just to make sure we're on the same page, were you saying that we should lay out something really well in terms of spec and then feed that into language model and have it? Okay, yeah. So it has been imported from day one, right, without AI. Right? And I think that people tend to jump into implementation right away because they have the spec in their head, so to speak, right? And then you just go ahead and do it. And then spec often become kind of a afterthought. Okay, let me document this afterwards, or let me write tests afterwards, or let me go and clarify the requirement with someone else halfway through my development, right? So I think in general that's definitely a good idea to do, whether you're using AI or not. It's very, very important if you want to do pure vibe coding to have really good spec. As you can see, Rishi was able to get some good results, but the really good one was the one that he wrote page-long, prompts to get the AI to do it. And I don't think he did it in one go, right? Which I imagine you have to be very iterative in terms of doing that. So same thing with spec. I don't think anyone can just sit down and say, okay, let me think through every single detail, write it out, and then get it right the first time. It's an iterative process. And then the nice thing about it is, at the end of the day, you don't have to throw away that thing and say, that was just a prompt, right? That, if you write it well, that becomes your documentation, right, at the end of the day, or becomes something that can communicate with someone else, say what this code is doing. So it is a very important skill to have. It has always been, but now probably even more important.
Any thought on prompt engineering?
So the question was, any thoughts on prompt engineering? Many thoughts. There are funny strategies that seem to work, but I feel like it is an over-discussed topic to an extent. Like, a better prompt is not always the same answer. A better prompt is not going to go from, here's my demo, to I'm shipping it tomorrow. You can ship it, it will break. That's fine. If you're okay with that, fine. But prompting well is less about, kind of to the same point, is it's less about these weird hacky tricks that happen to work with the current generation of models. I mean, we can see prompt engineering doesn't work because it's not the same for every model. That right away kind of blows it out of the water because this world moves too fast to have something that's only compliant with a certain generation. The thing is, good prompt engineering is just good writing. It's just good documentation. If you are detailed, if you are precise, thorough, concise, it will hopefully be the same. And there's so many tricks you can use to coerce the output to a certain pattern, but it's only helping yourself to do it well. And it doesn't have to be perfect every time. It's kind of scaled to the scope of the problem. If I'm asking you to convert a single visualization, I will write wow, fire, and then give me a good visualization. I'm not going to write a page. But if I want a data generator that does it well, I will write a page. That's just how it is, because we want to understand the expected behavior of the output from the beginning.
Thank you so much for the talk. I was wondering about, this is kind of still something that I'm thinking about in my own mind, but technical debt with respect to AI, right? When we say AI is thinking, are we actually saying we are now in the process of accumulating technical debt, right? Because what's happening with cognitive debt is I'm not paying attention to the task, and therefore I'm not processing it deeply, just shallow. So when we do something with AI, aren't we then accumulating technical debt because we don't understand it fully, and we're just hoping that it works? It looks really nice, it's documented very well, and I could go through and pretend I understand it. Maybe I do understand it, but a week later I'm not going to because I didn't go through the process of building it myself. So how do you feel about that?
That's a very funny question. So I'm going to talk about prompt engineering. They say prompt engineering was yesterday's job. Today's job is slop engineering. So there's a dedicated job of fixing AI slop, generated slop. I think it's absolutely right. Kind of linked back to the MIT research as well. I think there's a lot of value of, getting your hands dirty, so to speak, right? Actually get in there and do the work. For your own understanding, for your own learning, but also, like you said, you have, I think it's very difficult. Doesn't matter how good you are as an engineer or data scientist to, for AI to generate tens of thousands of lines of code, and you have, I review every single line of it in a very great detail. Humans are just not designed to do something like that. So a more iterative process is probably going to be a lot more helpful and easier to catch anything along the way. So I'm more of a proponent of, hey, maybe having more of a copilot sort of way of working with AI rather than YOLOing it. And there's certain YOLO cases, and that makes sense. One-off prototype and all that, yeah, of course. You don't want to spend too much time on it. But if this is production level code, it is much better to have AI helping you to accelerate the obvious, the tedious stuff. But you are still in charge. You're still in the driver's seat, right? You're just having, someone else that's helping you writing things a little bit faster. And then do it at a sort of incremental step rather than, hey, here's the entire thing, go help and write it. So yeah, that's just my personal bias, but I think there is definitely a group of people thinking in the same way as well. At least for now, with the current generation of LM, I don't think you will be able to have a lot of success by always delegating all the work, important production level work to LM and ask it to do it. And then, like you said, even if it does a great job, because you have no context whatsoever, it's basically non-maintainable. And a lot of time in engineering, making something maintainable is more important than making something that's fancy or run fast.
Along those lines, and looking at the employment figures that you showed, or the unemployment figures, if AI is used to generate code and some high-level programmer checks it out and so forth, and the lower-level programmers are fired, then you're not generating a new class of higher level programmers, and there's going to be a gap in the generation.
Yeah, it is a potential danger, right? That's assume this trend continues,
Yes.
right? Where you have fewer and fewer jobs for junior engineer, and then all jobs go to whoever is still around. And that generation gap. I think we have actually seen this in some other industries as well, right? Where I think the one I can remember, power engineers. It used to be obviously a very important job and a very sought after job. You have a lot of electricity to be built and all that. Now we have a big gap where a lot of engineers will choose to do computer science, for example, right, or some other, more fancy and more sexier job than good old power engineer. And then you have this problem of old engineer retiring. But I do believe in market dynamics, right? If you think of it that way, right now is yes, you don't need junior engineer, and at some point you'll probably need them. So the market hopefully will work itself out. Okay? But we'll see. We'll see. It really depends on how well this thing will keep evolving and keep getting better and doing pure development work.